Good weekend, guys. So today, I apologize first off for not getting this up till today, but we're up Saturday morning, and you guys should be good to go until Monday. Um, we are now starting the chapter on functions. Functions are not usually too difficult, but it does include some graphing and some other concepts that will be a little bit more difficult. So we're going to go ahead and get started with functions. And you'll hear me use some definitions um, throughout the lesson, and I will also have a slide at the end that I will post that I'll leave up for a few seconds to where you guys can write down the words and then get those definitions done. So the first thing we're going to do is we're going to look at plotting some points. Now, we're going to call these coordinates, all right? A coordinate, you hear of the word coordinate used in aviation, mapping, anything like that. And we're going to, actually, I'm going to go ahead and go to that definition slide page real quick. Um, a relation is just simply, it's a set of two numbers. It's a pair of coordinates is essentially what a relation is. Okay, and we're dealing with functions. Okay, and a function is going to be any uh, equation that is it's called one to one. All right, and what that means is that for every x value, there is only one y value. Okay, now that's different because for every y value, you can have more than one x. So I could have 2 comma 3, and I could have 5 comma 3. But I can't have 2 comma 3 and 2 comma 6. That means the second one I just gave is not a function. Okay. Um, Now let's go ahead and let's go back to the graph. We're going to start the origin just to get you guys familiar with the coordinate plane here. This is what we call a coordinate plane. This is our y-axis. This is our x-axis. Okay. Um, I'm also going to talk about quadrants. You hear of quadrants in when they section off different areas. They'll say this is quadrant 1 and this is quadrant 2. Okay. This is what we call quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And there's a few things you'll notice as we're working with coordinates and graphing and stuff that you'll get familiar with that kind of help you out. For example, I know that in this quadrant, quadrant 1, the y value is going to be positive and the x value is also going to be positive. I know in quadrant 3 that y value will be negative and the x value will also be negative. Now, when you're looking at coordinates or a relation, okay, in terms of x and y, since we're dealing with an x-axis and a y-axis, the first number is the x value, the second number is the y value. So when I plot these points, let's go ahead and we're going to plot letter A, and when I plot it, I'm going to label it as A, okay? So I'm going to plot 1. Now, 1 is the x value, and it's positive, which means this is what we call the origin right here, and this is 0, 0, okay? That is our origin. So we're going to start there. This is kind of like on a number line, you always start at 0. Well, it's the same idea. So we're going to start here at the origin, and I'm going to go positive 1. Well, if you think of a number line, whenever we go positive, you always go to the right. Negative always goes to the left. So I'm going to go right 1, and now I'm going to go positive 3 on the y, which means am I going to go up or am I going to go down? Well, whenever you think of positive and negative as far as higher or lower, the higher you go, the more positive you're going. The lower you go, the lower you're going. For example, sea level. When you go up in the mountains, you may be at like 5,000 feet above sea level. But you can get, as you get closer to the ocean, you get closer to 0 feet sea level. And then there are places in the world that are actually below sea level. So we're going to go 1, and we're going to go up 3, and I'm going to put a point. This is going to be labeled as A. Now I'm going to do, I'll actually use a different color. We're going to go to B. B, X is 4, so I'm going to go 1, 2, 3, 4. Y is 2, so I'm going to go up 2. 1, 2. This is letter B. We use blue, let's go to black. So for letter C, now we're looking at something a little bit different. Now we have a -3 and a -1. Well, just use that number line idea. Okay, so we're going to start at 0. And if I'm going horizontally, I always go right for positive, left for negative. So it's a -3 for X. So I'm going to go left 3. Oops, I didn't need to put a point there. Let me erase that real quick. But I am going to go 3 negative. And now the Y is negative. And again, we have to go to down. So we're going to put our point right here. Going back to that sea level example, you could think of the x-axis as sea level. That is 0 feet sea level. So you are standing at the ocean. When you're going up in a mountain, it goes up like this. This would be positive. And if I go into a valley, I would go down here, which would be negative. Okay, so that's another way you can think of it. And this is going to be letter C. And I will do green for D. And D is going to be, now we have a combination of a positive coordinate and a negative coordinate. So this time, X is going to be 1. So I'm going to go 1 on the X. And it says Y is -4. So I'm going to go down 1, 2, 3, 4. And this will be letter D. Okay, so that's all there is to plotting coordinates. It's not very hard to plot a point. The biggest mistake that I see students make is when they get a negative, sometimes they go the wrong direction. Okay, so always remember, a -Y, you go down. A -X, you go left. Positive X, you go right. Positive Y, you go up. Okay? Now, on example 2, this is a word problem, and you're going to see some word problems here in class on your worksheets you're going to be doing on Monday. Excuse me. When we do the example 2, all right, we have a table here. All right, so let's go ahead and read the question first. Use ordered pairs to represent the data for an approaching thunderstorm. Because there are 3 seconds between the flash and the sound when the storm is 1 mile away, the first ordered pair is 3, 1. Alright, so based on the information I'm given, the 3 is going to represent the seconds. Okay, so we've got 3 is the seconds, and the 1 represents how far away the storm is. Okay, so my X value is the total time in seconds. So this would be the X time in seconds. The distance in miles away is going to be your Y. All right, because if I look at the coordinate, this is always, X always comes first, alphabetical order, X, then Y. So X comes first, then Y. All right, so what they want us to do is they want us to take this information here and put it in a table. Okay, this is what we would call our X value, is what we would call our input. Okay, it determines the Y value, and we'll get more into some more of these definitions in the next few weeks, or in the next week. But the X is what we call the input. Okay, so I'm going to put a 3 here. Now, if the storm is 3 miles away, then, excuse me, if the flash, and I misspoke myself, if the flash, if there's 3 seconds between the flash and the sound, then the storm is 1 mile away. Okay? I don't say if the storm is 1 mile away, then the time between the flash and the sound is 3 seconds. Okay? We're saying that the time between the flash and the sound is 3 seconds, which means that the storm is only 1 mile away. Okay, so this is what we call our input, and by inputting 3 seconds, it means I get an output of 1. All right, now let's take the next one, 6-2. So now we've got 6 seconds and 2 miles, 9 seconds and 3 miles, 12 seconds and 4 miles, and then we're going to put these dots, which means that this pattern will continue. All right, so every 3 seconds you're going to add 1 more mile. So if I was going to do the very next one, let's just fill in 1 more box just so that I can show you this pattern. All right, so ignore the dots. So if I did the very next one, this would be 15 and 5. And I could go all the way out. All right, we could go as far as we possibly could, out to, 100. All right, you'd have 300 here, which means this would be 100 miles away. Okay, now we're going to plot these points right here. So the very first one is over 3, up 1. Point 2 is going to be over 6. And actually, we're going to run into a problem here because as I go, I'm going to go off the coordinates. So what we're going to do, to make this a little easier, instead of these each being worth 1, let's make each one worth 3 since we're going in coordinates of 3. So this would be 3, 6, 9, 12, 15, and so on. So we're going to go over 3, up 1, over 6, up 2, over 9, up 3, over 12, up 4. And you can see that this is actually making a line. And there are values that would be in between. For example, what if it was 3.5 seconds between the flash and the sound? Well, it's still going to have a value, just as if it was 0. Okay? Now, we can't have negative time. All right? The sound does not come before the flash. So we can't have a negative time. But we could have that there is no time between. You see the flash and you hear the sound at the same time. So we can start at 0, and we're... Oops, here, let me actually make this a little neater for you. We can start at 0, and we can actually draw... Move this down. We can draw a line between these points. And this line is going to continue. It's not going to stop because that could go on forever. Like we said, I could have 300 seconds between the sound and the flash and the sound, and and that would mean it's 100 miles away. So this is going to continue. Okay. Now, one thing I want you to get used to is I want you to get used to labeling your points. So this would be 12.4. This would be 9.3. This one would be 6.2, and this would be 3.1. Okay? So now we're filling in a table, and we're also plotting some points on example number 2. Example number 3 is going to bring us to our next 2 definitions. The first one is what we call a domain, and the second one is what we call the range. Now, this is going to directly tie into the x coordinate, the y coordinate, as well as the input and the output. Okay? So your domain is the set of all x values for the problem. Okay? Or you could say the domain is all of the inputs for the problem, because we know the input is also the x values. So, for example, we're going to identify the domain. So we're going to put a D. And this is how you represent set notation, is that little triple hump squiggly line thing. Alright, so now I'm going to look and I'm going to see in letter A, what is all the x values? Well, if you remember on our table, the x always comes first, the y goes second. So the x would be 1, 2, 3, 4. The range is all the y values. So that's 0.41, 0.58, 0.75, and 1.31. And we're going to ignore letter B. I forgot I was supposed to put some points on there, so just ignore letter B. It's the same idea though. Okay? Letter C, the domain. Well, when we work with a coordinate, what comes first? The x. What comes second? The y. So the x would be -4, -2, 0, 2, and 4. The range would be -11, -7, -3, 1, and 5. Okay, so I hope this helps make a little bit more sense. Domain is x, range is y. All right, and if you want to make the correlation between the alphabetical, D comes before R, so domain before range. X comes before Y, so X before Y. Domain is the X, range is the Y. Okay, so we talked briefly about a relation. We talked about a function. We talked about the origin and coordinates. And then we also talked about input and output, quadrant, domain, and range. And you're going to hear a lot of these definitions all throughout this entire chapter. Okay? So make sure you get your definitions done. I want your notes done. And then come prepared to class on Monday to get some work done as well.